Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Eli Dowling, who's been contributing to the Rock programming language, that is, the language I've been developing for the past several years, in his spare time. We talk about the intersection of language design and editor tooling, including topics like parsers that recover from errors, tree sitter, going beyond the language server protocol, and the downsides of macros. I want to give a massive thank you to everyone who's been supporting Software Unscripted on Patreon. If you enjoy these episodes and you'd like to become a supporter too, check out patreon.com/softwareunscripted. And now, tooling-aware language design. All right, Eli, thanks for joining me.
Hello.
So, you have been a contributor to the Rock project for quite a while, and sometimes I know exactly how someone got into Rock and how they found out about it, and but you're someone who just sort of arrived out of nowhere from my perspective, and I really appreciate your contributions. And one of the things that I always wonder whenever somebody does show up and just start making awesome contributions out of the blue is like, how did you find out about the project in the first place?
Well, I guess it's kind of a long journey. It started with learning functional programming. Not even quite sure where I got introduced to the idea, but my first FP language was F#, mostly just because I'd done .NET stuff before.
I think that's the usual path for F#. Yeah.
Yeah. And then from F#, kind of like exploring the wider ecosystem. Eventually, I think I encountered the research paper about Perseus, which I guess not everyone listening will necessarily know about, but Perseus is the way of doing high performance immutable data structures, I guess, using reference counting.
Yeah.
Which I would say is one of the key, hasn't been done before features of Rock. As far as what are you getting out of Rock that you're not getting anywhere else? I'd say that's high up my list. When doing functional programming, I feel like there's always this slight pain that comes from using a linked list. Every time I use a linked list, I'm like, another incredibly slow linked list. Lovely. Once you know a little bit about cache locality and really optimizing programs, you realize that every time you're using some of these immutable data structures, you're just kind of hurting performance a little bit. And I appreciate not micro optimizing, but I think there's something to be said for the fact that if you micro unoptimize everywhere, eventually your program does just end up slower.
Yeah, it's interesting because I always like to draw a distinction between persistent data structures and data structures that are semantically immutable in the sense that you can't change them, but they're not persistent in the sense that they're not designed to make it really cheap to clone them except for one part of that. So for example, linked lists are a good example of if you have a linked list and you're I want to clone the entire quote unquote linked list except for this one little part. Well, if that one little part happens to be the first element, then you're in really good shape because you can really cheaply do that. And now you sort of have both linked lists in memory, and the only difference is the first element. So that's persistent data structures, and those can be really useful, especially if you're trying to do things like save undo history or something like that, because then you actually want to preserve all of everything, but then with slight variations each time. And then like you were saying, Perseus is kind of about, and Rock too, is about the idea of, they called it functional but in place. And I like to call it opportunistic mutation, but they're the same idea. The idea being you have a more traditional sort of non-persistent data structure, like a flat array, which like you said, is a lot better for memory locality and everything else. And then now you don't get, if you have that, well, so what you do get is if you have Perseus, the reference counting, check to see if the reference count is 1 or do some of that at compile time, then you can update it in place without sacrificing the immutable semantics. But there is a trade-off there, and I want to be mindful of the fact that there is a downside in the sense that if you are trying to do something like undo or whatever, which in a lot of functional languages, because they use persistent data structures as their default, is really cheap and fast. In something like Rock, you'd actually have to switch from the default data structure to an explicitly persistent data structure to get something like that to be fast.
Sure. Yeah. Although I think you could definitely make an argument that not every problem is an undo list, and most problems are far more applicable to a well-optimized vector than just running around following pointers all over the place. And having that be your default for every problem is probably not a great idea from a general performance standpoint.
That's sort of my hypothesis, I guess, is that, there are cases where persistent data structures are exactly what you want, but they're relatively few and far between. It seems like the default that you usually want is to mutate in place. However, you also, at least I also would like immutable semantics, not for the performance reasons, but just because of the simplicity of like what it makes your program look like when it's sort of written out, and like the ability to understand what each individual function does and so on and so forth.
For sure. I mean, that's how I got into functional programming for the exact same reason. And I did end up actually building a fairly large program all on my own as my first piece of kind of software at the first company I worked at. And I would say that I attribute significantly like the success of that piece of software to building it entirely in F# and having everything be very easy to reason about the fairly complicated inner workings. I was in broadcast at the time, and it's reliability is pretty important when the news must go at 6 every single day.
Yeah, I've talked to a couple of people who've worked in domains like that. I'm curious how you found out about the Perseus paper in particular. Was it like, do you tend to read academic papers like as a hobby, or did you just kind of come across that particular one? Or
not quite that hardcore. I think I was just generally looking in the programming language world. I think like generally I've had a pretty strong interest in programming languages themselves. Like I think that probably extends wider, and we can kind of talk about what I've been doing in Rock. But it all kind of fits into the idea that I think tools are interesting. Like I think the tools that we use to make things are significant to the outcomes.
Totally, yeah. To put it mildly. So you found the Perseus paper somehow, even though like normally you're not reading a lot of papers. How did you get from Perseus to Rock?
I'm not even quite sure. I may have just looked up like references to the paper, like places that it was used. There's some chance I found Coca first, or Coca. I'm not sure.
I always say Coca.
Yeah.
Koka.
And from there, I may have found your talk about Rock. I think that was my first introduction. One of your early talks, just like outlining the like functional in place idea. I think it was. I believe it was the one where you did quicksort in Rock. And from that point onwards, I was kind of pretty, put it in the back burner and checked on it now and again. And as you guys got closer to releasing a new website and having everything kind of getting to the ready for people to look at this thing state, I thought it would be pretty cool to jump on and add a bit.
Yeah, I appreciate that. So I think your first project was it Tree Sitter? Was the first thing that you worked on? Yeah. So how did you find out about Tree Sitter?
Maybe the Helix editor would be my guess.
Interesting.
Yeah. So looking again, tools, right? I think they're interesting. So I was exploring text editors and encountered Helix. I'd done a bit of NeoVim. I tried Emacs before. It's all a bit painful, I think. Lots of config management and not a lot of actual programming at the end. And particularly like when I first tried NeoVim, it was before they did the whole integrating LSP thing, and it was pretty early days. And like the idea of installing a different editor extension for every language and it being just like a nightmare to configure just didn't appeal to me at all. So I ended up finding Helix, and then Helix uses Tree Sitter under the hood for all sorts of things. The highlighting, but also using like semantic navigation, which I think you'd be familiar with from Z. I think they have a similar thing where you can say like, I want to go to the previous function or the next argument in this function call or that kind of stuff, rather than kind of just clicking around.
Actually, the creator of Tree Sitter is one of the co-founders of Z. So
yeah.
Yes, we use it extensively.
And so anyway, I arrived and had a look at Rock, and then I was using Helix at the time, still am actually. And of course, Rock in Helix, because Helix uses Tree Sitter, is just white text, black background, full of sadness.
Yeah.
So I thought before I do anything, I got to improve on that situation.
Nice. Okay, so that makes sense. So this was sort of scratching a personal itch. It was like you wanted to use Rock in Helix, and that required Tree Sitter, or having a Tree Sitter grammar, because a lot of editors to this day, including Visual Studio Code, still use TextMate regular expressions. TextMate back in the day, which is a lot slower than Tree Sitter and also isn't as good at error recovery and yeah, a lot of downsides. There's a lot of reasons.
Much less semantic information. Yeah, it's just worse in every way.
Yeah. So it's funny because when you started working on that, I remember thinking, although I don't remember whether I said this out loud or not, but I remember thinking, I don't actually know like if Rock's syntax is sufficiently regular to make it into to be able to be implemented in as a tree sitter grammar, because there's a lot of people who set out to make a programming language, and one of the first things that they do is they make a grammar, like a formal grammar for the parser. I did not do that with Rock. I was like, okay, well, Elm has this syntax that I like, and I want to make some tweaks to it that are Rock specific, but that's kind of about it. Backpassing being the biggest one that's like pretty weird in terms of parsing. But honestly, I just kind of assumed like, well, if the parsing performance is good enough, then we're all set. I hadn't really thought about like what category of parser does this fall under, and what are the implications of that for something like tree sitter. Tree sitter was totally not even on my radar when I was first working on the syntax. So I was pleasantly surprised that it turned out that, yeah, it turns out you can make a nice regular tree sitter grammar out of it.
Well, I think like technically, I admit my understanding of tree sitter is not like world class or anything, but I believe you could technically pass anything in tree sitter because you can actually always escape out to a parser.c where you can then just do some arbitrary parsing shenanigans. Now, obviously, you don't want to write a parser in C. That's the whole point of tree sitter. So I wouldn't recommend that one as the default solution. But it did take a fair bit of mucking around. The documentation for tree sitter is not amazing. Mostly everything had to be based off reading other people's grammars and kind of checking what kind of hacks they did. And I think I rewrote it probably about 3 times before I got like a base structure that made sense. And it very much like figuring out the way to categorize like the most low level chunks was probably the most time consuming part. Just like going all the way down of like parsing the individual pieces and then realizing they just don't compose together properly and everything is completely stuffed. And then starting again, basically.
So which particular low level pieces are you thinking of here?
The idea of like what should you call a block of code, and like what is a block of code even, right? Like when you say define when you have like a definition, you have a equals something, you start this like scope, and like what kind of scope is that, and how does it differ from other scopes that you might start in, say, brackets or after backpassing, or like an indentation scope after a function, or even like the one that's like massive pain is binary operators. So sorry, just like generally just like operators. So where you have like addition and things like this, and sometimes they can stack, and sometimes they stack when when you're doing like pipelining, things like this, trying to figure out if I have like a function call and then I have a binary operator and then another binary operator and then another function call and everything's nested, and trying to figure out who belongs to what and where. It ends up being you have to like make this differentiation between certain scopes where you can have all types of things and some scopes where you can only have this like subset of things, like just a variable name or just a parenthesized expression. And they're quite common in the various grammars I looked at, and they're called they just refer to them as like atoms rather than complete expressions. And it's because that they should be able to fit basically anywhere, even within, and like unambiguous as to what belongs to that atom. That kind of makes sense.
Wow. Yeah. I'm reminded of the binary operator that has the most weird edge cases is minus or dash.
Okay. Because of...
So the tricky thing about it is I think it's 6 different positions that it can be in that are all relevant. So one is, maybe it's just 5 actually. Yeah, I think it's just 5. So there's 5 different positions that are relevant here. So one is you have spaces on both sides of the minus. So that's really easy because that means it's subtraction. The other is you have no space on either side of the minus. That's also easy. That's definitely subtraction. But what happens if you have, for example, x space minus y with no space? Well, now that probably means that what you want is you want to negate y. And it's like especially obvious if you have a number there. So it's like x space minus 1. That probably means x is a function. You want to call it passing -1. So that needs to be parsed differently because there's one space in front of it, but not a space after it. But then there's the fourth case is, what if you have a space after it, but not before it? So you have x minus space 1. Well, that's probably subtraction again, like x minus 1. Obviously, it's not a negative 1 because it's not, touching the 1. Or x minus space y, right? Again, subtraction. And then the fifth case is, what if there's a new line involved? So if you have I guess you could call that fifth and sixth, but yeah, if you have a new line instead of the space on either side, then again, it's kind of like, well, if you have the minus is touching the next thing, then we assume it's negative unless they're right side by side. So it's one of those things where you might look at that and say, well, your grammar is overcomplicated because you have that. But I think if you ask a human, what do each of these do, they're going to give you a consistent answer of yeah, this one's subtraction, this one's subtraction, this one's a function call of minus. And this doesn't come up in languages that do function calls with parentheses, because the parentheses sort of disambiguate that. It's specifically because we call functions with white space rather than parentheses that comes up at all. But fortunately, there is a nice consistent answer. It's not like, well, it really depends on the surrounding context. It just depends on those little spaces.
Yeah, look, I honestly, who knows what the tree sitter parser does? I don't know. Maybe it thinks it's all binary operators. And honestly, the great joy of writing a tree sitter parser is it doesn't matter because it's not functional. It doesn't affect the compilation of the program. As long as it gets all the colors right, who cares? It can be a little bit dodgy, which it is. I'm sure there are still edge cases in the tree sitter parser that no one's found because you don't notice them.
Yeah. Something I don't think people realize is how often different tools want to use different techniques for doing the same part of compilation. Like parsing being a really common one, but like in Rock's case, it's like you have the Rock parser that the compiler uses, and you have a separate parser for tree sitter, and you have a separate parser for TextMate grammars, and all of them are doing, are capable of doing syntax highlighting among other things. But you could look at that and say, that's a lot of duplicated effort. Why wouldn't you just, have one single source of truth, like code base that does all of them? And one of the answers to that is that they all have different outputs. You cannot just we don't want to write the Rock parser in regular expressions. That wouldn't work well at all. But that's what TextMate needs. And similarly, we have our own abstract syntax tree that has information that we keep around for, in some cases, error messages and stuff like that tree sitter doesn't use. So tree sitter also wants its own representation. And I've heard as going as far back as JetBrains, they would re-implement, as far as I've heard, their own version of the Java compiler of the type checker and stuff like that as well, because they had different needs in terms of diagnostics that were coming out and so forth, and performance and whatnot. So yeah, I think it's pretty common, and it's not necessarily incorrect, even though it might sound like it's incorrect.
Yeah, I mean, one of the disadvantages of the tree sitter parser, and I guess to an even greater degree the current Rock parser, is recoverability, right? Tree sitter is not super recoverable. Some parsers are a lot better. Tree sitter is kind of okay-ish. And in fact, there are things that you can do to a tree sitter parser to make it more recoverable that I've implemented in Rock, that you kind of you make a little bit more tolerant of things that are a little bit broken. And you mess with the syntax rules so that they don't strictly follow the actual language rules. So it can be just a little bit more hand wavy and be oh, well, look, that's an if and it's a bit broken, but it's fine. We'll still just call it an if.
Right.
Whereas obviously the current Rock parser is very intolerant.
Yeah, there's a definite interesting trade-off there between wanting to, if you're just doing syntax highlighting, wanting to do sort of a best guess and not stop and call things errors and just be well, you're an editor, so you're probably in the middle of writing something. So you don't want an error. You want all the syntax highlighting around it to just sort of look right until you finished, writing your thing. But then you have a different trade-off when it comes to the compiler itself. If you're doing a batch build, arguably you want it to be certainly less tolerant, I would say, in the sense that you want it to report errors. If you say look, this syntax is wrong, you at the very least need to tell the user that it's wrong.
Yeah.
But there's another argument for not sort of guessing it makes sense to do in the syntax highlighter, because let's say that I'm going through and I hit a parsing error and I'm well, I'm pretty sure this is a blah blah blah. I'm just going to assume that's correct and just keep going with the rest of this. When you get your errors from the compiler, you're not just getting syntax errors, you're getting other compilation errors as well, like type mismatches and things like that. So if you incorrectly parse something and it's not actually what the user intended, you might end up flooding the user with bogus type mismatches and stuff like that, all because you tried to be, recoverable on the parser side of things. And I think Andrew Kelly wrote a blog post, or somebody on the Zig team wrote a blog post about this idea of, I forget the term they used, but it was something along the lines of points of like breaking the parser. So a really good example of this in Rock would be a top level declaration, like when you've indented all the way back out to column 0. At that point, we can say, okay, no matter what was going on inside that declaration, we know we've now hit the point of that's the end of that declaration. So if there was a syntax error in there anywhere, we can say, okay, that declaration is messed up and we're not going to try to type check or do anything with that. But all the rest of the declarations in the module, they're fair game. They might still be fine. And then you can take that to, you can apply that same idea to other constructs that you're parsing. For example, string literals. So if you have like a single quoted string literal that's only allowed to go on one line, if you have an open quote and then you don't close the quote at the end of the line, at least the semantics of Rock are like, well, that's a single line string. So you have an error, which is that you forgot to close the quote, but at least we don't have to treat the rest of the everything else that you parse.
You can move on.
Yeah. Although you still could have spurious type mismatches for that. For example, let's say you're calling a function, you pass it foo bar and then open quote something, and then you forget a close quote and there's more arguments after where the close quote should have been. Well, now you're going to get a type mismatch saying, hey, you didn't pass enough arguments to this function, when actually what happened is that you didn't close the quote. So that again, there's that trade-off of like, how localized do you want it to be relative to how many spurious type errors are you okay with getting as a consequence of trying to be graceful about recovering the parsing errors?
Yeah, I hadn't really thought about just how much of an issue that is in Rock. Well, because of the, total type inference, no type annotations, the level of like really confusing error that you can get by having a recoverable type, like type checker and parser, is kind of on a bit of a different scope of, like escaping the place of the actual problem.
I'm sure that's true to some degree. I wonder how big of a deal it is. My guess would be that it's not that big of a deal. It's interesting, like people talk about a downside of type inference being that if you don't, of type inference everywhere, like Rock has, where you don't have to write any type annotations if you don't want to, being that if you do that in practice, then you can get like, you make a mistake over here and then it sort of propagates all throughout the program, and you don't have any of these sort of cutoff points of like, okay, well, at this point, I expect the type to be here, to be this. I've never found that argument very compelling. Granted, I've never worked in a code base that does that. I've heard that in certain OCaml code bases, maybe this is just older ones, that culturally that was a thing that people would do sometimes, is they would just not actually write type annotations on any of their top level functions. But the thing is, Elm has the same property that Rock does of like complete type inference, but it's just a very strong cultural norm that you always write type annotations for your top level declarations. And actually, there was a while where you could just in your editor say like, hey, infer this type declaration for me. And that's like, to me, one of the cool things about type inference is that if you want, you can write your code without type annotations and then press a button and say infer it. Idris has the coolest demos of this because they can like, it's like dependently typed, and so you can fill in certain things. Like you can go either way, I guess. I think from like either there's like certain declarations, type declarations, where there's only one possible implementation and it can sort of fill that in for you, or there's like a small number of them.
Yeah, that makes sense.
But I really like the ability to start with either. Like if I'm writing a little like shell script replacement, which I mean, shell scripting is one of the sort of use cases that I have in mind for like something I want to use Rock for. In that case, I probably don't want to write type annotations on anything. I just want to I'm just focused on like do this IO, do that IO, etc. Whereas in a lot of other cases, in fact, the majority of the time, I'm starting with the type annotation because I'm trying to figure out how the pieces fit together, and then I do the implementation later based on that. I think the nice thing about type inference is that you can do either, and you can start with the implementation, and in fact, you can then later add a type annotation and have the compiler infer that for you. It feels to me a bit like the criticism of like, I don't want type inference everywhere is almost saying like ... because I don't want to follow that style guideline of like choosing to annotate the top level functions. Because if the annotations are there, then you're basically back in the world of like Rust, for example, which requires type annotations on all functions, but not for closures, in the middle of defined in the middle of functions, which there's no distinction there in Rock. But I don't really see the downside of like giving you the option of going either way if you're going to end up with, in a substantially large code base anyway, with the type annotations being there. Does it matter that you got there via type inference or not? I could see an argument for having a compiler warning, like if you don't annotate your top level functions, but I don't know. At the end of the day, it feels like that's just such a strong cultural norm in Elm that it feels like if you can just establish that as a cultural norm, it seems to work out fine in my experience.
Yeah, I can see an argument for having a like a compiler warning for exposed unannotated types. So something that goes through all of your, a bit like the equivalent of OCaml's MLI files, right? Like when you define something that is exposed, it has to have an annotation that defines what type it should be. I don't entirely agree with that as an idea. I don't actually like that in OCaml, but I do think there's an argument that certain portions of your API should always have annotated types, even just so that you are notified when you change those types, so that when you accidentally change the implementation a little bit and then suddenly you're now outputting a result rather than not a result or something, or a task rather than a result, your consumers aren't suddenly very surprised. And I know you've talked about how Elm has makes a demand upon your exposed interface that it must match the previous types, or it won't let you bump versions, and that's how it controls semantic versioning. But obviously, if Rock doesn't have something like that, a requirement that you have to define those exported types will tell you if that's changed, because you'll now have a compile error.
Yeah, I do definitely want to have that, where like if you publish something to a package index, which we don't have a package index yet, but if in a world where we
One
do,
day.
I would definitely want to have the like semantic versioning is automatically enforced. And by the way, that does work with just type inference. Like you if you want to, you can just publish the module and like we can just infer the type annotation, and then we can tell whether or not it was a major bump or not.
But on that topic of type inference and like propagating errors and things like that, I would say that in my experience writing Rock, not expansive, but some experience, probably in the top 1% of the world.
Yes, easily.
My most common frustration is like the intersection of having what is it? So when you have record types, they're structurally typed rather than nominatively typed. It's nominatively typed, right? Yeah.
Nominally, yeah.
Nominally typed, sorry. And same with the like tag unions. That combines to mean that sometimes the type errors are just really confusing and far away from the problem, and also extremely long. And they're almost always because I've fat fingered a type name somewhere. I've like got a tag one letter wrong, and now the error is somewhere far away from the tag that I've actually gotten wrong.
Right.
And I would say that is my major like hurdle with writing inference code. And I have the same problem in other languages sometimes as well, like OCaml. But Rocket, I think, has this like intersection of all of these features which make it particularly nasty to be able to, because it won't tell you, hey, you haven't defined this tag. It won't tell you, hey, you haven't defined this record field. It just runs away with it off into the distance. That's probably the major reason that I, in other languages and Rock as well, mostly my type annotations tend to be in line at a point where I suddenly realize that something's going wrong, and I would like to say 100% sure that at this point this thing should be a string. Like I've done some like parsing, and I've done some messing with it and some results and things like that, and like I know that at this point I should have a string, and if I don't have a string, give me an error somewhere else. Like that's it. I would say that that's probably the main way I would try and like resolve those errors in other languages as well as Rock.
Yeah, so that's an interesting example of something where I think there's room for improvement in the compiler, like to give nicer error messages. And one of the tricks you can do, which we don't currently do, but which I would like to explore trying out, is having this idea of sort of provenance of like where the type comes from. Like, for example, did it come from a type annotation? Did it come from a type alias? Or did it just come from an anonymous literal? And then later on, if you get a conflict where it says this type didn't match up with this type, we can sort of say, well, this type came from a type alias. So that seems like a stronger indication that that's what you meant, that like that's what you intended. And this one's probably the error. And then hopefully we can suggest something like, hey, this record field has this field name and it's trying to be used with something that comes from this type alias, which has it defined as that. So probably like ideally the sort of the hint message can be like, hey, probably, did this field be that field? And we do some of that already, but we don't have the concept of like, which one do we think is correct? Like based on where it originated. And I think that would hopefully help. I know that we also do quite a bit of diffing. So like if you have two records that are like 8 out of 9 fields are exactly the same, then we just reduce those to ... dots, which I think does help in those cases. But I also know that unfortunately, sometimes you can get it like really nested, right? Like you have like a list of records, and like one of those has another record listed in there. And then that like triply nested inner record is the one where you have the typo. And so even though we can use the ... on all the surrounding fields, it's still like going to be like list of record of ... of record of ... of, so yeah, I don't know if that's what you're referring to, but like that is an example.
You can get these explosions of type errors, right? Like, or like the other one is like results with heaps of accumulated error types, or where it's just, you just get, instead of getting a reasonable error message, you just get like half a page of type. And it's just like something in here is wrong.
I think that's one where we probably could do more diffing and like dotting, like ellipsing. I don't know what the term is for that. Because I mean, there was some point where I was running into, I forget what it was, but I was running into some issue with records, and I was like, I'm just going to sit down and write the like diffing for this, and it's just kind of a big manual chunk of work. And I thought I did that with tag unions later, but maybe not. But hey, that's a potentially interesting project. If you or anybody else listening is interested in working on that, definitely like, I'm always looking for ways that we can make error messages nicer. And I don't know about you, but for me, it seems like there's right now a skewed bimodal distribution where it's like the vast majority of errors are like very helpful and very quick to resolve. And then there's a very small number of them that are sort of like, oh, these are really like painful. And so I guess that's not bimodal at all. But I guess the point I'm trying to make is that I don't have a lot of like middle ground errors where I'm like, oh, this error is like kind of confusing. It's like usually it's like either really easy and immediately I understand what's going wrong, or it's like really big because there's some sort of, there's just like a lot of types involved, and it wasn't able to, at least currently able to like elide enough of those or diff enough of those to boil it down to like, here's what the problem most likely is. Yeah.
Talking about that, it's interesting because you probably could do a really good job of inferring what types should be by doing a bit of the same diffing, right? Like if you see a record and 4 out of the 5 fields are matching another record that is somewhere else a type that you have in the program, and then one of the fields is, you can even do like an autocomplete, like a fuzzy find, right? You can say like this other field matches other than 2 letters which are different. You could just have an error that just says, hey, like we're 90% sure you meant this field, right, and you've got it wrong, right? Or same thing with a tag, right? Like this tag is used 5 other places in the program, and in this one place you've got 1 extra letter on the end. You could just show an error that just says, hey, like we're pretty sure this should be this other thing.
Yeah, there's this interesting design question around error messages and hints, which is, should you start with a hint or end with a hint? Because you could say like, hey, here's an error, and then up front you say, I think this is what the problem is, and just tell you like, I think this field should be this other field. It's like a typo for this other field. And then below that you could say, I'm like, here's the reason I think this. It's, all these types are the same, but this one field is different. A downside of that is that it can signal sort of overconfidence, because at the end of the day, these are just heuristics, like you said, right? I mean, it's like, well, if there's 2 letters different, like, Levenshtein distance of 2, like, well, then we think it's probably a typo. But if it's 3, now we don't think it's a typo anymore, right? But of course, you can have typos of like 3 letters. So there's just this, there's this question of like, should we tell you? And we sort of inherited this design from Elm, where Elm is very consistent about, here's the error, and then if we have like, here's the information that we know is true. Like this definitely had this mismatch with this other thing. And then below that, it will say, here is some additional like information, context, hint, whatever, that says like, hey, I think it's probably this. Like, maybe did you do this wrong? And what I like about that is that it makes the compiler sort of trustworthy in the sense that it's like, it's always starting with, here is the thing that we know for sure. And then afterwards, it's like, let me try to be helpful on top of that. My nervousness around swapping the order of that is that if you stop reading, you maybe got the incorrect, heuristic-based hint. Sure. Rather than and you miss the thing that was like actually like this is the truth. But I could see an argument for maybe if you can find the right wording for it that sort of communicates like, here's what I think is the problem, and then below that is like, here's why I think that. Maybe that could end up being a really good user experience.
I do think for some of those hints, like it's extremely obvious if the hint is not relevant, right? Like if the hint is you have this other record, like this record field is almost the same as this other record field. Did you mean that one? The answer is yes or no, right? Like as the programmer, it's like, no, I did not. Okay, right. I read the error message, right? Or it's yes and thank you. For some of them, I can imagine the hint could be a lot more ambiguous, particularly if you're talking about like structural things, where it's like, did you actually mean to put this other piece of code here? Or when you're talking about like tasks and the kind of mess that you can get into there, or if you think you're writing JavaScript for a while and you put all your tasks in the wrong places and end up not propagating properly and things like this, where I'm sure we could come up with pretty good hints to help people coming from other languages get used to the bang syntax and things like that.
Yeah, there's another interesting question around like usually whatever you start with in terms of context needs to have the sort of line numbers associated with it so you can see where the problem is. So I could imagine for the record field typo example, maybe the error message could start off with, hey, it looks like this field is wrong. And I think you would need the provenance tracking for that in order to say like, this field looks wrong because it came from a literal rather than from a type alias. And then show that like, in context with the line number and like, here's the exact one that I think is wrong. And then below that, or maybe you could even cut more to the chase and have the first sentence of the error message be, should this field name be blah ? It's like, that's the one we think it is. And then you show that. And I guess the question mark would be maybe a hint that it's like, we're not saying it is, or it needs to be, but yeah, it's like, we're starting with a question, which feels on the one hand, potentially awesome, because I definitely find myself with like Elm and Rock errors. Like I just jump to the end reflexively to look at the hint because that's usually the most straightforward thing. So maybe if we did start with that, it could be a time saver, even if it does sound in the abstract a little bit weird to be like, there's an error. And then we start with like, did you want to do this? And then we tell you what the error actually was afterwards. But yeah, as counterintuitive as it might sound, maybe that's actually a better design.
I think if they are right in the majority of cases, then the majority of the time I'm going to want to say yes. And if it's extremely obvious if they're wrong, then there's no harm done, right? Like if it's a one-liner, you just scroll down and you're like, no, that's not it. Okay, show me the error. I feel like the potential time saving of just being able to immediately see, oh yeah, that's the thing, and then just do it. And then, if you really want to get fancy, you integrate it into the editor and then you make it a code action. And then when you mouse over, it says, put the thing there. And then you press the button, it puts the thing there, and fixes it for you.
Yeah, that would be really cool. I mean, now that I work at a company that makes an editor, I have all of these interesting things that I'd always sort of thought about as like, oh, this is something that like, the dedicated Rock editor can do. But now sort of like, oh, I mean, maybe every editor could do that. One of the things we've chatted about is there's like the language server protocol has been extremely successful at getting a lot of like really useful functionality into a lot of different editors across a lot of languages. And it has really addressed very successfully the problem of like, you have N editors and M languages and people don't want to re-implement, the same functionality for like across that whole matrix. The combinatorics there are not forgiving. But a frustration that I have with the language server is that in terms of its capabilities of like what it offers you, it's pretty much like 1990s era, like state of the art, with like maybe a couple of extra things. And I would really love to see some sort of advancement in that area of like, let's like expand what's possible here. Let's like for example, the like, have the compiler be able to say, here's exactly the edit that I think would fix this problem, and then just, let you do that, as opposed to that still being kind of, actually, I haven't looked comprehensively through the whole language server docs to see if this exists, but as far as I know, it doesn't exist. There's no way to say like that there's, but it seems like that's the type of thing that it seems like there could be a way to have the language server sort of get more involved in not just saying what things are about the code, but also in interacting with fixing them.
I don't believe there's currently a way to do that from an error message, but you could include in your error message the suggestion to use a code action to fix it. And then you could provide a contextual code action that then does do that operation. But there is definitely a few extensions that I would also like in that area to things, specifically things like code lenses, which is, I'm not sure if Zed supports them currently. They're one of those things that's like, because it's Microsoft's language server protocol and Microsoft has VS Code, gets the special treatment. And so there's a few features that are still, VS Code specific, but also in the language server protocol. There are some nice things you can do with code lenses where you show a little bit of text. I was exploring this when we were talking about potentially including a feature in the language server that shows whether your function is tail recursive, because that's like a massive beginner oopsie in functional programming, right? Like you write a function and it's dog slow, and it's like, why is it really slow? And well, it's not tail recursive, and so you're throwing stack frames all over the place, and all sorts of problems. But when I first learned functional programming, I certainly had times when I was like, what is tail recursion? And is this function tail recursive? And how do I know? I still have times when I'm working with mutually recursive functions where I don't know if they're mutually tail recursive, because then you get deep in the rabbit hole with that one. And I don't think Rock supports mutual tail recursion optimization. Does it?
I don't think we do. No, I think it's just self-tail recursion. I mean, certainly there was a time where we only optimized self-tail recursive functions, and I believe that time is still now.
Cool. Yeah, so it would be great, right, if your editor just said, hey, this function is recursive, but not tail recursive. Are you sure this is what you wanted out of this function? It would be especially great if, when you say clicked on that, it showed you the function call that you're calling and then doing something after that makes it not tail recursive. That would be amazing. But unfortunately, code lenses, you could do it in VS Code, but you can't do it anywhere else. But with some extensions to the language server protocol, which I totally agree, should definitely focus more on getting some really cool modern editor features out the door. You could totally do stuff like that. And it would be amazing if they could be immediately supported in Zed and Helix and NeoVim and Emacs and, your dad's weird editor that he wrote in his garage, like everything, right? That's the point.
Yeah, I love the idea of the tail recursion annotation. While this idea we talked about, which I think I proposed this in the ideas channel on Zulu, but the wildest idea of this was like, what if we just made it a warning if you have a function that's not tail recursive? Because it is always possible to express any recursive function as a while loop, and tail recursion is how you express while loops in a purely functional language. So why not? Why not just say, like, if it's not tail recursive, rewrite it to be tail recursive? But other people made some good points around. There are some algorithms where it's like, look, this is going to be massively painful to rewrite as a tail recursive thing, and you like the performance benefit you get from that would not be noticeable. So just don't make that a compiler warning. Because which is a fair point. But I would love to make it as easy as possible, to make it so that if you want your function to be tail recursive, you can. The dream would be not only do we have an editor little annotation that says, hey, this function is or isn't tail recursive, then there's a button that says make it tail recursive. Because in theory, that's a mechanical transformation. Like you can take any,
that's something you can do.
Well, in the sense that, I mean, it has to be, right? Because in theory, if it is the case that any non-tail recursive function can be rewritten as a tail recursive function because recursion and while loops are equivalently powerful, then there has to be a mechanical way to do that, because somebody wrote the proof that must demonstrate that that's possible. How hard is that to implement? I have no idea.
Possible and feasible.
I'm sure it's not easy. But it definitely seems like the type of thing where if you could figure out a way to make that exists, then that would just be so nice. You could just like press one button and be like, yeah, great. It's a long-term idea, maybe. I don't even want to call it a goal because I don't know how feasible it is in practice, but yeah, it'd be great. Like just press one button, get better performance. Love it.
Yeah. I definitely think there's a lot of space to be explored there in improvements to I don't know, like the things that your editor could show you about your code that would be much more useful than just text. You know, again, on that same theme, right? Like because of Rock's, immutable but in place updates, or optimistic in place updates, you could also have annotations that show those, right? You could have something that shows in your editor, yes, this is being in place updated because there are no other references, and we know that statically before. And then you can just, you could even go so far as to have some kind of annotation that you do in your editor that just says like, all this code, I should not have any non-optimized updates, so that you know that in your hot loop, you're not like cloning things all over the place. And in fact, you could probably do the same thing with the tail recursion, right? Like a compromise could be that you have a comment or an annotation above your function that says the compiler should warn me about this function if it's not tail recursive, which would be like an intermediate compromise between having the fancy editor features and the world that we live in now.
Yeah, there's definitely some interesting trade-offs around all of that. One of the things that I think about a lot is where do you draw the line as like in terms of language design? Where do you draw the line of what annotations are useful and worthwhile, and what annotations are just everyone's going to start feeling obliged to clutter up their code with these because they want to be absolutely sure? And yeah, I'm just not sure exactly where the right place is to draw that line. Like tail recursion is a pretty good example of that, where on the one hand, you could say like, yeah, I want the compiler to tell me if I've stopped making my function tail recursive, if I break that somehow. On the other hand, you could make the argument that that's not that common of a thing to mess up. Like once you've written the function to be tail recursive, it's not like oopsie, I accidentally called it again recursively, but not tail recursively in like some weird branch. I mean, it could happen, but I just haven't seen that happen much in practice. It's usually like you get it down once and you're like, okay, we're good now. But you can imagine like for a lot of different languages and a lot of different optimizations, there's this same question of should you have a language level way to say, this or that guarantee? Like for example, conditional versus non-conditional branches. Like this is something I think about a lot in a lot of my compiler code is like, there's cmove, the cmove instruction, which has no chance of branch misprediction. And then there's, branches that can potentially mispredict, and that can have a huge performance difference, like, 10x, depending on whether you have a misprediction or not. Both of those come from if. It's just a question of like, does the compiler optimize it to a cmove or not? And you can make an argument of like, I would love to have a compiler annotation or like maybe a separate construct called like cmove if or something, but with a better name, that lets me guarantee at compile time that this is definitely a branchless instruction. But then where does that stop? Like you could also say like, well, sometimes you also have like you're calling a function, and if that function comes from a variable, then that variable, the address might not be known. So now there's a potential misprediction in terms of like what address it's going to jump to, but not if it gets inline sufficiently. If it gets inline sufficiently, then it's maybe known at compile time, and now it's an unconditional jump. So maybe I want to annotate that too. And there's just this, you can go on like this forever. And so at some point you have to sort of decide as a language designer, like for this particular language, do I want to add this, extremely long list of annotations of like different performance guarantees that you want the compiler to tell you about? At which point, every single time someone's writing a new function or a new like anything in this language, there's this new decision where I'm like, I'm writing this function, I'm going to make it tail recursive. Do I add the annotation or not? Or I'm writing this function, I want the like in-place optimizations to always happen. Do I add that? That actually, the in-place optimization one, it's come up a lot in discussions of like people saying, I want to add a guarantee of like, give me a compiler error if this particular thing, ever gets called with a non-unique value. And I think there's a lot of problems with that in terms of API design. It means that like now you're specifying, I mean, you're kind of getting into the like, now we have not necessarily linear types, maybe affine types, I don't know, but like something where it's like you can no longer just call a function. You can't just be like, oh, here's the type of the function, I can just call it. Now, every single call site, you potentially have to be like, well, hang on a sec. Like I'm calling it and the way that I'm calling it is okay now, but maybe in the future you have this like one code path where it might potentially be shared. And so now all bets are off, even if in practice at runtime, the reference count would always be 1. It's really easy to go overboard without realizing you're going overboard, or sacrificing the simplicity of the like decision points around when you're just writing a function. How much do I have to think about? What things am I choosing to use or choosing to not use? Without realizing it.
Yeah, look, I do think some of that is. I would argue that I don't know if that's something I've ever seen in other languages be a problem. So, for example, F# has an inline keyword, right? You can say, I want this function to be inlined. I've never seen that inline keyword used in any code base other than ones where the inline keyword was very necessary, right? Other than like ultra high performance code, I've never seen it used anywhere. Another example is OCaml has annotations to tell the compiler to inline things and like do a bunch of other optimizations and things. And again, I've never encountered them out in the wild until I learn about them reading about the compiler. And I think that it is okay to have a feature in your compiler or in your language that like 99% of people will just never use. The 1% of people who are library authors or like writing ultra high performance code that other people can use, who use them, will really appreciate them and might like make the ecosystem better. And the rest of the people will never and should never learn about them. Like that's fine. Like you never have to know that this annotation exists to guarantee this like in-place mutation thing. And because like if you did, it would just cause you pain, right? Like the reality is that like most code should not require only in-place mutations. That's awful.
Yeah, I appreciate that. At the same time, I think a point that I would push back on is the idea that just because I think there's more of a downside than just looking at how often does this feature get used in practice. One of my very good friends mentioned like when he was first learning Elm, one of the things that sort of stood out to him compared to, I mean, he's a lot of different programming languages. Elm is like, I don't know, double digits of like, in the like numbers of languages that he's used. And he said one of the things that he really came to appreciate about it very quickly is that when you're getting to a point in Elm where you're like, all right, I need to make a decision about what I'm going to do next. Like, how am I going to implement this particular thing? He said the decision tree in Elm is extremely small. I'm not thinking about like, should I do it this way or that way? Should I do it this way or that way? I'm like, no, there's like a couple of like obvious options, and I'm just going to very quickly pick one of them and sort of go down that. And I think that gets amplified the more sort of you're building in a language like that. It's not just that it saves you time not thinking about the other things, but it's also that it prevents your mind from wandering and getting distracted thinking about alternatives that 99% of the time don't matter for this particular case. But because you know that they're there, you're still thinking about them. And I think inline's a good potential example of that. I definitely do think about on a pretty regular basis with my Rust code, like, hang on, should I make this inline? And sometimes I'm just like, yes, obviously. Other times I'm like, yes, obviously, but it's one line, so I'm pretty sure the compiler is going to inline it anyway. Do I really need to tell it, like, hey, you should definitely inline this? And then other times I'm like, most of the time I'm like, it's fine. But I always think about it, and it always distracts me a little bit. It pulls me a little bit out of the context of what I'm doing. And in a language like Rust, I think it's totally appropriate to have an inline keyword because, it's very performance focused. You need to have that level of control. But I wonder about, for a language like Rock, is that cost of having everybody always be thinking about, should I use this keyword because it exists? Is that worth the potential performance benefit? Because at the end of the day, inline is a pretty interesting example of something where like you can always get the optimization if you want. If nothing else, you can just copy paste because that's what inlining does. That makes your maintainability worse. But the point is that if you really, really are sure that you absolutely need that performance, you 100% can get. It's always achievable in user space. And, granted with ergonomic trade-offs. Another interesting question there, though, is I think about inline is typically an annotation that you put on the function. Zig has both options. You can either put the annotation on the function or you can put it at the call site. So you can do an inline call. Be like, right here, I want to inline this whole function and call it. Like an idea I've been sort of kicking around is I wonder if What if we introduce the call site one, but not the function declaration one? And the thing that I like about that is that when I am at the point of calling a function, that's when I'm thinking about, oh man, do I really want to call this function, or do I want to like just, do I want to have the potential overhead of a function call here because I'm inside a really hot loop or something like that? Or do I want to be really sure that I'm not doing that? And I think my intuition, although I haven't spent a ton of time thinking about this, is that I suspect that the amount of mental energy it would take me to answer that question is actually a lot lower at the call site than at the function site, especially because at the function site, that's where I'm thinking about, like, am I really going to annotate all these one-line functions as inline always? Because, like, come on, like, the compiler is probably going to optimize that for me. Whereas, like, basically, like, the question I'm sort of guessing is, like, do I need to add this extra annotation to my code, or is that just going to be ceremony that doesn't change anything because the compiler was going to use the, heuristic to inline this anyway? Whereas at the call side, I could just be like, yeah, you know what? Like, it's important here that this not be a real full function call. It's moving stuff around on the stack. Like, I actually want to just like do that. I'm still getting the heuristic based one, but then maybe I'm getting less mental energy expended on making the decision at the point of call site. I don't know.
I do think if you're interested in lowering the number of potential questions you have to ask about whether you should inline things, having an option every time you call a function makes that a hell of a lot more than every time you define a function.
That's a very good counterpoint to that. Yeah. I mean, the thing about all of these things is that I think a lot about, like, how does a language feel to use and why does it feel that way to use it? And I think a lot of these decisions, like, it's very easy to go from a language that feels very sort of lightweight and feels like you don't have a lot of mental overhead to write code in it or to understand what the code is doing. The way that you go from a language that feels that way to a language that feels more stressful to use and just like it's taking up more of your mental energy, et cetera, is usually due to the accumulation of features that were designed to solve a particular edge case. And so that's why I try to be very, very cautious and like conservative about adding features that fit that description, especially if there's a workaround that you can do without the feature, such as like editor annotations that tell you about tail calls, editor tooling that tells you about like when this might or might not be guaranteed to be mutated in place, etc.
Yeah, look, I agree. I do think there's I do definitely think there's something to be said though for empowering people and making it obvious that most people shouldn't know about it. Like the combination of those two ideas, right? Like, as I said, for example, the OCaml feature for inlining, you have to like know the specific syntax you have to write in a comment above your function. And no one normally writing OCaml will have any idea that this syntax exists. You have to like read the docs on the compiler optimization flags and stuff. And that's fine, and that's how it should be, right? But I also think there is also the fact that, for example, OCaml, one of its great supporters is the company Jane Street. I don't know if you're familiar at all with Jane Street, right? Like, Jane Street wouldn't use OCaml if OCaml didn't have the weird optimization features it has, right? Like, one of the things Jane Street uses OCaml for is very high performance programming and programming that doesn't allocate and things like this, which are not normally very doable. And one of the reasons that they can is because OCaml has a bunch of these weird features that most people never ever use that exist so that you can do very high performance things occasionally. It's almost like the whole idea of like Python. Python is mostly not Python for data science stuff, right? Python is actually C for data science. Yeah. And people writing Python need to know that. They don't know that. They don't know it's Fortran under the hood, and they should never know, and they never have to write Fortran. But someone did get to, right, in this weird other way that was useful. And I guess Rock almost has that with the platforms thing anyway, in some ways. But I don't know. I do think that empowering people is useful, even if you're empowering the right people rather than most people.
It's definitely useful. One of the questions I always ask myself there is that, let's say that I'm in that very small niche of users, it's like, how much do I feel that I need to be catered to versus like what's possible versus what is I don't know, maximally ergonomic. So what I mean by that is like, is it possible for me to get this performance out of Rock? I think the answer in almost all cases is going to be yes, there's some way to get that. So if I'm Jane Street or something like that and I'm totally blocked on this, like there's some way that I can get the Rock compiler to get the performance that I want. The question is, how ergonomic is it? And that's where I think the trade-off really lies, is it's about like, what is the ergonomics of adding this feature for this small group relative to what is the ergonomic cost to everybody else for having that feature exist and potentially need to think about it. I do have a personal pet peeve around semantic comments where like you have stuff in like, to me, comments, it's like, I think it's useful to have a distinction between comments and documentation comments. Documentation comments being things that'll like end up in generated docs. But that's it. Like I really, it is like an absolute explicit goal of mine to never have comments do anything other than those two things in Rock. Because as soon as you get into the like, well, this comment, like if there's an at right here, then now it's a load bearing comment. And actually, if you take it out, it changes the meaning of the program. That really bothers me. I'm like, if it's going to be a keyword, like if it's going to be a feature in the language, make it be part of the language, not part of the, special like magical comment syntax. I understand why a lot of languages
totally agree with that.
Yeah.
No.
It's a pet peeve for sure.
I do think the comment syntax in that case is more of an example of the fact that it feels bad to use, right? Like in OCaml, it feels like I probably shouldn't be using this weird comment thing. And like it's like I feel like it's almost probably repulsive by design, right? Like maybe it is just bad. Who knows?
I'd be curious to hear, if that was something that was on people's minds. It's so weird to. We always do a lot of archaeology to try to figure out what languages do because it's so rare to actually get to talk to the people who were involved in the design decisions and stuff like that. But I always really enjoy those conversations when I do get to talk to people and find out like, oh, that was why you did it that way. It was like this is a conscious decision versus like, oh no, actually, like very often it turns out it's like, oh yeah. The reason we did that way, oh god, it's this whole history behind it, and it's like has nothing to do with what you would think. A lot of language decisions turn out to like not be like carefully considered intentional things, but rather just like particular confluence of events leads that language to have that feature with that design.
Yeah, it's the old, well, it was the one we could all agree on, so, it was the solution. It wasn't a good one, but we all agreed it was okay-ish.
Awesome. Well, yeah, we talked about a lot of stuff. Is there anything else we should discuss before we wrap up?
I mean, one very thing I had, I have a little collection of notes here about this chat. And there was one thing that I thought might be an interesting little side tangent, which was the fact that Rock doesn't have a macro system.
True.
And I think I have a theory that every language that doesn't have a macro system eventually will end up with one.
Okay, so
it might be really bad, but they'll get one eventually.
Okay, so what would be something that you think people would use macros for in Rock?
Well, we use macros in the Rock compiler, right? To do generate, decode implementations.
Right, but Rust and Rock are different languages. I mean, like something that you currently like.
We use like macros, right? Like we do a thing where we read some Rock code and then we generate the typed representation of Rock in the Rock compiler and then output it into your code. So we like have a really crappy macro system in the Rock compiler for writing Rock to some degree.
Sure. Yes, but that is a macro system in Rust, right? Because the Rock compiler is written in Rust.
Sorry, go on.
Like, let's say that, like, what is something that if you're sitting down, you're like, I'm going to write a Rock program in .rock files. What would be the motivating use case where it's like, I really wish that these .rock files had let me write macros in them?
Well, one argument would be that you could implement our current decode implementation in Rock rather than in the compiler. That would be one argument.
Oh, so the implementation of the actual, yeah, okay, but I don't know. Speaking as someone who works on the Rock compiler, I don't feel the need to like we already have something that works. It's fine.
Sure, but you could argue that it's like a feature that we needed to make the language work that isn't available to people continuing to work in the language. That sort of suggests that there are a class of problems that need that to be solved. And the other thing that suggests that is the fact that every language that I know of has a macro system, or didn't have a macro system and then had one added, or has a really bad thing that's almost a macro system that was like shoehorned on around the real language.
I mean, I certainly agree that a lot of languages have macro systems. One of the things that I think about when it comes to macro systems is, and the reason I ask about like, what are the specific problems that they would solve in Rock is that I think macros are an instrument that is used for a lot of different purposes. And in some cases, like a really common one is basically just like you want the code to look a certain way. And you can't do that with normal function calls. There's too many parentheses or whatever. And so you reach for a macro because it allows you to write code that looks a certain way. In some cases, that's because you're just like, well, I want it to look a little bit nicer. I think when you have function calls that are separated by white space, I don't have any desire for macros to like try to improve on that. It's like, it's already so clean and like clutter free that like, I don't personally ever feel that a macro would help with that. Another more advanced use case example of using a macro for syntax reasons is you have some sort of configuration file that needs to be in YAML or JSON or whatever, and you want to just have that in your code and then reference that directly, and then have a macro sort of parse it on the fly and then turn it into whatever. I guess this is like maybe kind of a special case of like templating or something like that. But again, in that particular case where you have this, JSON or whatever else, we already have a potential solution for that, which is you can already import arbitrary files as strings into Rock. So now you have your JSON file imported into Rock as a string. Another feature that I want to add to the compiler that we've talked about several times is compile time evaluation of constants. So if you have something that is a constant, we will just evaluate that completely at compile time, which we can do safely because it's all pure functions. So at that point, without using any macro at all, you can just have a function that sort of says, parse my JSON or YAML or whatever, import that file statically as a string. And now, again, it's like, what's the use case for the macro? You could take that a step further and say, well, I want to templatize that in a way where I have like, custom $ strings in the middle of this thing. And I want to, turn those. But again, if you're parsing it as JSON, you can also parse, these $ things and apply, whatever variables you want to, substitute into there. And that can all happen with compile time evaluation. And if there are any errors in that, those can also be surfaced at compile time. So I give these as examples of cases where my goal is that Rock doesn't need a macro system because if you enumerate all the different use cases that people have for macros, we already have a good answer, a good way to do all of those things, or at least so close to all of those things that the idea of adding a macro system just for the very small sliver of things that are left just seems like obviously overkill. That's my goal.
So I totally agree that implementing language features without clear use cases is the path to madness, and I think making C++ again. A couple of use cases that I think are interesting of macro systems that I've used. So like hygienic macros, firstly, I think are great. So like macros where you're basically writing normal code, but it just happens to have like a compile time element. One good example of a case where that has been useful, I wrote a little bit of code in Nim at one point, and something that really sort of surprised and impressed me was in Nim, if you are writing code to interface with a microcontroller, for example, you can have that code when you address a pin in the microcontroller, you can have at compile time, it'll say that pin doesn't exist because the macros inside the, when you call to like address a pin, it calls a macro instead of just a straight function. And that macro checks whether that pin is within the range of the selected board that you're compiling for. So assuming that the integer is like a constant, it will check to make sure that it is correct. So you can't like address a pin that doesn't exist.
So that would be an example of, I think, compile time evaluation of constants gets you that, right? Because if you're just doing function calls at compile time and all those function calls are referencing these constants, at some point, fundamentally what's happening there is you have some sort of list of these integers somewhere, and then you have some code that's running to check if this particular thing that you're doing is inside that valid range. To me, the essence of what's giving you that user experience is the fact that you have code that's being evaluated at compile time against known constants.
But it wouldn't work, I don't think, if you ran the because you're just like calling this function somewhere. You're saying like, I don't know, like set pin 1 high, right? I imagine that when you're evaluating constants at compile time, you're evaluating all your like top levels, right? But if this function is just somewhere deep inside, and then inside this set pin function, it then checks to make sure that the pin is one of the valid pins, that wouldn't run at compile time, right?
We can do hoisting. In other words, if you have something in the middle of a function that doesn't depend on any of the function's arguments, then it's effectively top level. You just put it in there for scoping reasons because you didn't want it to be available. But we can evaluate, and I think should evaluate, all of those things at compile time.
I think in this case, it would still be one of the function's arguments, right? Like the set pin high function would have an argument that is the pin number.
Okay, but if you want that function to evaluate at compile time, is that pin that you are checking like a valid number, I don't see how NIM or any language could possibly do that without compile time knowledge of what the valid numbers are, right?
Yeah. So you're saying that you could even hoist it out of the function call to get the you continue with the compile time evaluation in all the places that it's used. Is that correct?
Yeah. So basically, anything that is reachable sort of from the top level, like if you have a call chain that originates with something that either is at the top level or is effectively top level because it doesn't depend on any arguments. Those are all things like that I think should be eligible for and therefore should be evaluated at compile time, which in turn would mean that if there's any scenario where at compile time you know that this function is being called with this particular argument and the set of allowed arguments with their powers combined, it should get evaluated at compile time. The only way it shouldn't get evaluated at compile time and give you that error at compile time would be if the function doesn't get called at compile time. It gets called based on things that are only knowable at runtime, at which point I don't think the macro would be able to help either. I guess the one argument you could make for a macro being potentially meaningfully different would be if you call the function and some of the arguments come at runtime, but maybe like one of the arguments comes is like hard coded at compile time. Then there's a question of like, well, could we like go through and evaluate that? I haven't really thought about that particular example. Two things I would wonder there. One is, could the compiler be smart enough to figure that out anyway? Maybe, maybe not. But two would be, if I am the person writing this microcontroller code, could I split things up such that like I don't call the function that way? Like maybe there's a function that calls another function, and so one of them ends up, being able to do the top level evaluation thing, or even just like there's a function that's being called that always gets the same, hard coded argument, and inside that function is the check. It seems like there would be some way to get that user experience just using compile time evaluation of constants, even if you didn't necessarily get it in exactly the same. Like user code didn't look exactly the same as
it would be possible. The other major use case I would say that could be nice is much more in the like full on macro of just like generate AST kind of stuff of like we were talking a while back about currently it's kind of annoying to represent certain types in Rock, like enum types are currently very verbose because you have to define an opaque type for the enum, and then you have to define all these decoders and encoders and all of this kind of thing, and you could just macro that into existence.
Specifically, this is an enum where you are telling it which numbers correspond to which.
You're interoperating with some other languages enums.
Yeah, right. It's only like customized.
Yeah, if you're trying to use string enums from TypeScript or number enums from TypeScript, or some arbitrary JSON data or things like this, would be another place that they would be useful.
I think that one is actually a missing language feature. I don't think that's something I would like to solve with macros, because even if you had a macro that could generate the code that sets up all the pattern matching and this and that to convert back and forth, that's still going to be worse performance than just telling the compiler like this is this number and so forth. Yeah, I remember we had like a very brief language discussion somewhere on Zulip about how we want to do that, but I think the reason not to use macros there is not so much that that could be a reasonable solution, but rather that currently, if you have that exact use case, we don't have like like the best performance that we could have for it. And I think the only way to get that is a language feature, at which point, again, I don't think there's a need for a macro.
Yeah, no, I think that I do agree that the language feature is definitely the better solution in that case. I do still think that macros are an interesting, like, convergent design that does seem to be ever present. And I would love to know more about them. Like, I admit I've never used, Lisp, and so I don't know what it's like to live in the world of macros. Not truly.
The number one reason that I want to try to never have any macro system in Rock is that they just destroy editor functionality. And whenever I say that, someone's like, okay. Oh, no, like, surely not. Like, look, Rust has macros and Rust has great, editor support. I'm like, if you do a print line in Rust and you use string interpolation in that, the editor has no idea that exists. It has no idea what the string interpolation means. If you hover over it, it doesn't know like what its type is. If you do a refactor rename, it won't rename things in interpolations. It's just completely clueless. And we're talking about the most basic, most like long-standing, like this is like, so, I mean, maybe it's possible in theory, but I think it should be a red flag that as far as I know, it's like never been done well. Like there's never been we have a macro system and it just works great with all the editor tooling. It's really, really important to me that Rock is a language that works really well with editor tooling. And so I think it's like very much worth preserving that and not, I agree that like lots of languages do it, but like I think they suffer the consequences of that with error tooling, and I don't want to suffer those consequences.
I think it's interesting that you bring that up as a disadvantage when I probably would have brought that up as an advantage of having integrated macros, because most of the languages that I've worked in that don't have an integrated macro system end up with a macro system that is not integrated, in that like it's some kind of cobbled together thing that works on top of the language that then like generates something that then goes into the compiler, or like that you run as a generator one time off. I think Go has quite a lot of that, where you just like you have a bunch of annotations in your code and it just like runs through and parses the code and just generates more Go code. I've seen it. It's a thing. They don't have macros, and that's what they have instead. And that seems like the worst solution. That's like the worst possible situation, where your editor, not only is it not useful, it like you can't even view the source code properly, and like if your editor experience just doesn't even exist anymore, right? In those situations. Yeah, I think it's as I said, I just thought it was an interesting topic to bring up, in that it seems, as I said, to be very convergent. That languages, even languages that didn't have a macro system for a long time, end up with one eventually anyway.
I can't argue with the history on that one. However, I mean, part of the reason to make a new programming language is wanting to do things better than the existing crop of languages do. And one of the ways I think Rock can do better is by saying all of your editor tooling always works 100% of the time. There's no language feature that you can reach for that will just break your ability to like hover over something and see what its type is, or rename it and have actually every single instance get renamed and things like that.
Yeah, I think that's a good goal.
Yeah,
consistency.
And like definitely, it's not trivial to try to achieve the same level of functionality that you would get from macros, or at least the relevant part. There's always going to be some long tail there of things that macros can do that you can't do any other way. But at the end of the day, yeah, I feel good about like. Currently, I don't know of any use cases of macros where I'm like, man, it would be really great in Rock if you had that. That's not either already implemented or like on the roadmap, and something we definitely want to do.
Yeah, cool.
Fingers crossed.
Yeah. Hopefully, I do very much appreciate the less is more approach to language design. I think it's definitely a noble thing to strive for.
Nice.
Alrighty.
Awesome. Well, Eli, thanks so much for talking to me about all this. This is really fun.
Thank you.
And thanks again for all your awesome contributions to Rock. And
my pleasure.
Yeah, for talking about all these cool things. All right, I'll see you around.
See ya. Have a lovely evening.
That's it for this one. I hope you enjoyed it. You can find links to some of the things we talked about in the show notes. And if you've been enjoying these episodes, consider supporting the show on Patreon at patreon.com/softwareunscripted. Until next time.